13 January 2026, and we are solving this basic sheet of unit number 2 of current electricity. And question number 1, 2, 3 we have solved in the last class, and today we are solving question number 4. The question number 4 is, what is the base unit of volt? What is the base unit of volt? Sir, what is the meaning of base unit? Base unit means you can express the unit of a physical quantity by using five basic quantities. You can use kilogram, you can use meter, you can use seconds, you can use amperes, and you can use Kelvin. These are five basic physical quantities. So you can use only these five physical quantities. Okay, so I am explaining. Now we are calculating the base unit of volt. Volt is potential difference, and potential difference is work done per unit charge. Work done is force into displacement. Charge is denoted by Q. Force is equal to MA and charge is equals to I into T. Charge is the charge is the product of current into time. Charge is equals to I into T. And now I am putting the units. Mass is kilogram. Acceleration is meter per second square, distance in meter, current in ampere, time in seconds. And if you simplify, then it becomes kg meter square, ampere minus 1. If you shift this ampere in numerator, and this second becomes second minus 3, second minus 3. And usually we do not read minus, we read per. This minus is read as per. So I am reading kg meter square per ampere per second cube. And if you compare this unit with given options, then the right answer is D. Then the right answer is D. So this is the base unit of potential difference. Jibit Abdullah, have you noted? Okay, beta. And now the next question is, ampere can be expressed as. Ampere means current. Current is rate of flow of charge. The unit of charge is coulomb. The unit of time is second. So it becomes coulomb per second. And yes, ampere. Ampere is the unit of current, and ampere can be expressed as coulomb per second. Okay. And now the next question is about resistance. The next question is about resistance. Resistance is V equals to IR. Voltage, sir, voltage is work done per unit charge, work done, work per unit charge. Unit of work is joule, unit of charge is coulomb. So volt is equals to joule per coulomb. Volt is equals to joule per coulomb. And here is current. Current, sir, current is Q upon T. And Q upon T means it is coulomb per second. Coulomb per second. And now I am solving R. So this coulomb becomes coulomb square. So this joule remain as it is. Second remain as it is. But coulomb into coulomb, it becomes coulomb square. And this coulomb square becomes per coulomb square. This coulomb becomes per coulomb square. And now if you compare with the given options, then the answer is joule per coulomb square into second. So the right answer is C. The right answer is C. Jibda, have you noted? Abdullah? Okay, beta. And now we have a question number 7. The question number 7 is we have an electrical component. Sorry, all electrical components have resistance. Yes, it is right. All electrical components have resistance. In which of the following situation would the resistance not increase? In which resistance not increase? So now we are discussing situation. Situation number 1. Sir, if we increase current through a filament lamp, sir, when current is increased, then lamp becomes hot and its temperature will increase. When increase current, it will increase brightness of the lamp, it will increase the temperature of the lamp. So lamp becomes hot, temperature increase, and when temperature increase, its resistance will increase. So this is not the answer. We are searching not increase. So A is not answer. And now B. Increasing the temperature of metal wire. Sir, if the temperature increase, its resistance will increase. But the behavior of thermistor is not simple. When increasing the temperature, yes, sir, when temperature increased for thermistor, sir, temperature increase, then resistance will decrease. For thermistor, when temperature increases, its resistance decreases, not increase. Temperature increase, resistance will decrease. So this is our required answer. Sir, why? I will explain you. I will explain you why the temperature, why when the temperature of thermistor increase, sir, why its resistance decrease. I will explain. I will explain. And now question number 8. So this question is about series circuit, and we haven't studied series parallel. We will solve this question today, but right now it is not possible. Question number 9. The current is 0.2 ampere. You are given time 3 hours and you have to calculate charge. Charge is the product of current into time. Sir, current is 0.2 ampere and the time is 3 hours. And there are 3600 seconds in each hour. So, but Manahil, can you answer me if you multiply these numbers? हाँ बेटा. Okay, so the right answer is A. Okay, and now the next question is about question number 10. Question number 10, you are given energy, you are given voltage, you are given voltage, you are given time, and you have to calculate charge. You have to calculate charge. You are given voltage and energy. Voltage is work done per unit charge or energy per unit charge. So charge is equal to work or energy having same meaning. So you can interchange voltage and charge. And now I am using the values. Energy, sir, energy is 4200. Voltage, EMF is 1.5. And what is the answer? And in this question, you are given time for no use. You are given energy 4200 divided by 1.5, then obviously answer will be, what is the answer? I think it should be 6300, I think. Okay, but so this is also very simple question. And now question number 11. In question number 11, you are given current, you are given time, and you have to calculate charge. So charge is the product of current into time. So the current is 250 milliampere, 250 milliampere, and the time is 3 minutes, and the time is 3 minutes. And if you multiply all these numbers, then you can calculate charge. So I am not asking to calculate. I'm not asking to calculate. Leave it. And now the question number 12. Sir, you are given voltage, you are given current, and what is the resistance of the torch bulb? Okay. Actually, you are given some specification for torch bulb. You are given specification of torch bulb, then obviously you will use the specification of the torch. Okay. So V equals to IR. We are given a specification from the company. Company given, sir, voltage is 2.4, then the current is 270 milliampere, and then you can calculate resistance. I am asking you to calculate this number because in this question you are given two different values of volts, so it may confuse you. Okay, so 2.4 divided by 270 exponent minus 3, because we should use the given specification, and I think the answer will be D. I think the answer will be, हाँ हाँ कितना आ रहा है? Okay, 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 okay. So right answer is C. Okay, okay. So sir, we are given specification of the torch length and we should use it. So specification voltage 2.4, current 270, you have calculated resistance. And now this question I am not going to solve. Abdullah will answer me. Abdullah, this is a filament lamp and very simple question. What is the graph of filament lamp? A, B, C, D. Which graph is for filament lamp? And remember, filament lamp becomes hot, its temperature increase, its resistance increase, and whenever resistance increase, then curve bends away from current axis. Ji Abdullah, lamp becomes hot, and if the lamp becomes hot, then temperature increase, resistance increase, then what is the answer, Abdullah? In which graph the curve is bending away from the current axis, yeah? B, you are right. You are right. Because this is current axis and the graph bending away from current axis. It is bending away from current axis. Okay, number one. Number two, when there is very small current, then the temperature of the lamp does not increase. Okay, so it is not necessary कि बिल्कुल शुरू से ही वो bend होना शुरू हो जाए. आखिर में जाके bend हो रहा है, but bending away from the current axis. So your answer is right. Option B is the graph for filament lamp. And now Simra beta, which is diode graph? Which is diode graph, Simra? Yes, you are right. It is C, because when polarity of source is reversed, there is no current. This means okay, this is graph of diode. And now this is a question about LDR. You should know this is a symbol of LDR. Okay. And in this LDR, you should know a temperature resistance is inversely proportional with brightness of light. Resistance is inversely proportional with brightness of light. Okay. So now I am going to explain. The question is uh, the LDR now placed in a dark room. LDR is now placed in a dark room. If it is placed in a dark room, then obviously brightness decreased. Sir, if brightness decreased, then its resistance will increase. And according to Ohm's law, if resistance increase, then its voltage will increase. Its voltage will increase. Sir, in daytime, voltmeter reading was 3 volt. In daytime, the voltmeter reading was 3 volt, but at the dark room, its voltage will increase. Its voltage will increase. So the right answer will be C. So LDR is a light sensor. When you, huh, because there is another resistor which is in series. Okay, beta. Another resistance, it is in series, then obviously it will also sharing some voltage. So it is not possible कि सारा voltage LDR ले लेगा. तो थोड़ा बहुत तो बेटा बराबर वाले को भी ले देगा ना. सही है. तो जो there is a fixed resistor which is also sharing some voltage, so it is not possible कि whole voltage will be on the LDR. Okay, now this is a question for series parallel, which I cannot explain. This is a series question. And now this is another question which we can solve. The question is, sir, we have a thermistor as well as I think there is LDR. Yeah, this is the LDR. Yes, LDR. Okay. So in this question, sir, resistors. We have two resistors, LDR and thermistor. We have two resistors, thermistor and LDR. They are connected in series. Okay. In this question, they are asking, I need highest resistance. You know, for highest resistance, temperature of thermistor should be low. If the temperature is low, then resistance will be high. Okay. And if LDR is placed in a dark room, it means the brightness of the light will be low. When brightness is low, then resistance will be high. So we are interested in high resistance. So temperature should be low and there should be darkness. So the right answer is A. For thermistor, low temperature means cold room and low brightness means dark room. So the right answer is A. If you place this circuit in a dark and cold room, then obviously resistance will be highest. And now when a semiconductor. Sir, what is the meaning of semiconductor? Actually, there are three types of material. Number one, conductor, sir, which can conduct current. Insulator, sir, which cannot conduct current. But there is a material whose properties lie between conductor and insulator. This is known as semiconductor. And remember, diode is made of semiconductor, thermistor composed of semiconductor, So what is semiconductor? Semiconductor, it is not in your course. I am giving you explanation. This explanation is not in your course. Silicon, silicon is a semiconductor. You know silicon, you studied chemistry. Silicon is a semiconductor when silicon is in a pure form. When silicon is in a pure form, then it does not conduct electricity. But if we mix some impurity, I'm not explaining what impurity. This is not in your course. It is called doping. If I mix some impurity in the silicon, then it becomes conductor. It means silicon, when silicon is pure, when silicon is pure, it is insulator. It cannot conduct electricity. But we mix, when it is doped, then silicon becomes conductor and it is a very good conductor. So it is called semiconductor. So it is not in your course, इसलिए मुझे ज्यादा लंबी नहीं करनी चाहिए. खैर, diode and thermistor are made of semiconductor. And now the question is, when a semiconductor has temperature increase, its resistance decrease. The question is why? The question is why? So I think I am going to explain this topic on a blank page. I should explain you this topic on a blank page. Okay, I am explaining. Okay, explanation of temperature with resistance. Okay, for semiconductor material. I am going to explain. Okay. अच्छा बेटा, in current electricity chapter, we use capital N and small n in your course. This capital N always represent total number of electrons. Total number of electrons. Capital N always stands for total number of electrons in the whole conductor. Consider you have a metal rod. Its length consider 10 meter, thickness consider 2 meter square, etc. So length may be any number, area may be any number. It contains total number of electron, it is capital N. Okay, but small n means number of electrons per unit volume. And you know, in physics, whenever any physical quantity is divided by area or divided by volume, then it is called density. If you divide mass by volume, it is called mass density. If you divide charge by volume, it is called charge density. If you divide flux by volume, it is called flux density in A2 level physics. So density means when any physical quantity is divided by volume or divided by area, then it is called density. So this small n is also density. Why? Because it is dividing volume. Okay. So small n is number of electron per unit volume. So we can say that it is density. And what density? It is not mass density. So it is called number density. So the proper name of small n is, note down this name. This is in your course. Small n is number density of electron. No, no, no. We cannot use the term electron. In current electricity, we use term electric charge, electric charge or charge carrier, charge carrier. So I'm repeating and Simra will explain. Simra beta, what is the difference between capital N and small n? Sir, capital N is total number of electron in the whole conductor. Capital N is the total number of electron in the whole conductor. But when total number of electron divided by volume, it is small n, and its proper name is number density of charge carrier. Small n is number density of charge carrier. Small n is number density of charge carrier. G Simra, what is the difference between capital N and small n? Huh? Yes, this is called number density of charge carrier, and I specially show this term in your marking scheme. Read this term, number charge carrier per unit volume. Okay, this is number charge carrier per unit volume, which is also known as number density of charge carrier. No? Number density of charge carrier. In your marking scheme, they are writing per unit volume, but I use this term as number density of charge carrier. And remember, the answer of question number 18 is also D. I'm going to explain, but let me explain something first. G, I think you have understood the difference between small n and capital N. Sir, capital N means total number of electrons in the whole conductor. Small n is number of electron per unit volume. And now, sir, what is the significance of small n? Sir, what is the significance of small n? So the answer is this number density of charge carrier determines how good a material, a good conductor. So what does it mean? You know, copper is a good conductor. Steel is a conductor, but it is not as good as copper. Steel is not a good conductor, although it is a conductor, but not good conductor. Sir, why? So the answer is the number density, number density of charge carrier for copper is high. It means per unit volume of copper contain large number of free electrons. So copper is a good conductor. And for steel, number density is low. And if the number density is low, then obviously steel contain less number of free electrons in per unit volume. So the availability of free electrons in a copper is high, and availability of free electron for the conduction of current in steel is low. So copper is a good conductor and steel is a poor conductor. Okay, so this N determines which material is a good conductor. Copper is a good conductor. Why? Because its number density of charge carrier is high. Okay, and number density of steel, for steel, number density of charge carrier is low. And I think now you have understood what is the significance of a small n. And now I am going to explain that question. I am going to explain that question. So the question is, consider we are studying thermistor, and consider this is an atom of thermistor. This is an atom of thermistor. This is another atom of thermistor. Okay. And electrons, these electrons, consider these electrons are very close to the nucleus. Very close to the nucleus. And these electrons are not free electrons. Why? Sir, because they are tightly controlled by the nucleus. These electrons are not free electrons. These electrons are tightly controlled by the nucleus. But when the temperature of thermistor increases, when the temperature of thermistor increases, then these electrons absorb thermal energy. Temperature increase means there is thermal energy. So these electrons absorb heat energy. This electron absorb heat energy. And you know, when electron absorb heat energy, then they jump into high energy level. They jump into high energy level. And if the energy is sufficient, then these electrons leave their parent atoms, and now these electrons move as a free electron. These electrons now move as a free electron. In this way, number of electrons per unit volume will increase. Number of electrons per unit volume will increase. And I think if you write its proper answer, you should write proper answer, beta. When temperature increase, electrons absorb heat energy and jump from their orbits and becomes free electron. Okay, but when temperature increase, electrons absorb heat energy. When they absorb thermal energy, they jump from their orbits, and when they jump from their orbits, they become free electrons. And when they becomes free electron, it means number density of charge carrier. Number density of charge carrier will increase. Now, the availability of free electron increase. And you know, when availability of free electron increase, then it increases current. And when current increases, it shows the resistance decrease. It shows the resistance decrease. अब्दुल्ला गौर से सुनना आपसे पूछूंगा सर जब टेम्परेचर बढ़ता है ना सर जब टेम्परेचर बढ़ता है तो इलेक्ट्रॉन सर थर्मल एनर्जी एब्जॉर्ब कर लेते हैं सर जब उनकी एनर्जी बढ़ती है ना तो वो छलांग लगाकर एटम में से बाहर आ जाते हैं सर अब छलांग लगा के बाहर आ जाते हैं तो फ्री इलेक्ट्रॉन बढ़ जाते हैं सर फ्री इलेक्ट्रॉन तो हम लोग लिखते नहीं है तो हम कहते हैं कि चार्ज कैरियर की डेंसिटी बढ़ गई और आपको याद है अगर चार्ज कैरियर की डेंसिटी बढ़ जाए नंबर डेंसिटी ऑफ चार्ज कैरियर बढ़ जाए तो इट बिकम्स अ गुड कंडक्टर एंड इफ इट बिकम्स अ गुड कंडक्टर इट मींस रेजिस्टेंस डिक्रीज अब्दुल्ला बेटा कुछ भी समझाओ मुझे जब थर्मिस्टर गर्म हो जाता है तो उसकी रेजिस्टेंस क्यों कम हो जाती है बताइए बेटा हाँ 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 और जब नंबर डेंसिटी बढ़ जाएगी ना किसी भी मटेरियल की इफ द नंबर डेंसिटी इंक्रीज इट मींस कि अब वो एक अच्छा कंडक्टर बन गया है इट मींस कि बेटा वो एक अच्छा कंडक्टर बन गया है और जब वो अच्छा कंडक्टर बन गया तो जाहिर सी बात है मैं कहूंगा उसकी रेजिस्टेंस डिक्रीज हो गई है। ठीक है। एंड आई थिंक इफ यू रीड दिस आंसर नाउ, तो अब आप मेरी बात समझ लोगे। जरा गौर से सुनना, क्वेश्चन नंबर 18 समझा रहा हूँ। क्वेश्चन नंबर 18 बेटा, क्वेश्चन नंबर 18। सर, जब सेमीकंडक्टर यानी थर्मिस्टर का टेम्परेचर इंक्रीज होता है तो उसकी रेजिस्टेंस डिक्रीज हो जाती है, वजह बताएं। तो रीजन ये है कि सर नंबर डेंसिटी ऑफ चार्ज कैरियर इंक्रीज, नंबर डेंसिटी ऑफ चार्ज कैरियर इंक्रीज, नंबर डेंसिटी बढ़ जाती है, इसलिए सर उसकी रेजिस्टेंस डिक्रीज हो जाती है। ठीक है जी। तो बेटा इसको हम यहीं पे स्टॉप करेंगे।